So, for the latecomers, this is about trying to make database changes as comfortable as possible. It's not easy, you all know that. So, context. I'm talking about myself just because I like to talk about myself. I used to be an academic, and that's why I'm standing in front of you. I'm just practicing lecturing because I've almost forgotten. For the last 6 years or so, I've been a Perl web developer at the headquarters, mostly. And in the last year or so, I've been doing more DevOps kind of work. And so I've been seeing these problems of managing systems on the next release and how to manage the release cycle. And I've been putting together Perl solutions to these kinds of problems. In particular, in this case, database patching or change management. And also, the reason I'm half asleep is because since 12 until half an hour ago, I was teaching my Deep Uni dancing course. So if you'd like to do that, go to Deep Uni and I will teach you. So, wrong keyboard. Right, so why is this worth a talk? Because changing a database, I'm thinking SQL, is hard. When you have a new app and you've got some new code, you just trash the old one, you install the new one, everything's good. But there's data. The inconvenient truth that there's data from the previous release and you can't just push it. Your employer loves the data more than they love you, okay? And in spite of the fact that your Perl code is beautiful, that's not really what they value. So you've got to preserve the data. So whenever you're writing code, you have to make sure that changes that you require of the database are backward compatible. Don't go renaming fields, all right? Because if that happens and you run your database patch and something goes wrong with the installation, you have to roll back the old code, everything is going to break. Okay? So add a column. I know it seems inefficient, it seems like a waste of space, but you don't go renaming. You need to have some way of ensuring that the app that you're running has a version of the database that it's comfortable with. Whether it be storing a version of the database or checking something about the database so you know that you're allowed to run against it, the app or whoever's managing the apps should ensure that they're in sync somehow. The other thing is that you want to have some kind of forward and backward compatibility. So you make a change to the database, make sure that that's not going to be incompatible with what's currently running live. And similarly, when you're doing a new release, make sure it runs okay with the current database structure and leave the extra features which require a change to a subsequent release which has a database patch in between. And this sounds pedantic and people don't want to do it, and we sometimes don't do it at that corner. Happily, there haven't been any major disasters yet, but it's just asking for trouble. Something which would really help is if you're releasing often. And what we've tried to change a lot at Netquarter is to have frequent releases. And now, even on our old systems, we're releasing 2-3 times a week. Okay? And if we can do it, you can do it too. And at that point, you really can, release the database change and then release the code which depends on it. And it doesn't slow things up too much. So this is the way that we've been doing it up until now in many of our systems. You're doing a deployment. So you yum install the new RPM. The RPM install process, either when you're installing the RPM or when the code first runs, says, oh, okay, I've got to change the databases. I've got to add some columns, do whatever. And this is a little bit dangerous, okay? Because if the database patches take place, then you realize that the app's not really got to roll back, and then it's incompatible with your code. It's bad. And the other thing is that there's very little scope for rolling back unless you really, really strictly it up what I was saying and making sure that your database patches are okay with the old version of the code, etc. So, in detail, you'd have database refactoring in the install the RPM, and then you go to install the RPM, or when you're even roll back. Right, so the first problem which I should have mentioned is that we have lots of different apps on the portal, and every app has this built in a different way. We have no common ground for the way that we update our databases. That's the first problem. Next problem is that when you're doing the patches, whether it be on installing the RPM or starting the app, what happens if you need to scale up and have multiple apps in one database? Should they both be trying to update the database? I hope not. But that's more code you have to write to ensure there's no conflict like that. So this is the solution which I've put together. And who knows Jenkins? Who's seen Jenkins or used it? Or okay, so it's not completely unfamiliar. So instead of doing an RPM deploy like we did before, first thing Jenkins does is it says, here are some patches. Here's the database refactoring. Go to the DB refactoring service, and this DB refactoring service then makes whatever changes to the two databases or whatever number of databases that this app is relying on. And then, and only then, does it RPM install the new app. Now, the database refactoring service, what is that? There are a number of options of code which is being written specifically for that. And Net-a-Porter, every team up to now has been writing its own code to do this. It's simple, I know, run this SQL on that database. But the infrastructure behind that, with all the edge cases, why don't you just let someone else look after that? So I looked at these three, Liquibase, Liquibase, and DB deploy. And here is what I chose. I chose Liquibase because it's sort of being commercialized. It's still open source, but there's a company which is backing it and maintaining it. So I thought, yeah, it has all the features that anything else has. And DB deploy is evolved and uses this, and the Java developers at Net-a-Porter refused to let me get near it. So the point, I think, so it's written in Java, sorry about that, but it has tagging, and it's a bit like a Git for patches, for database refactoring scripts. It's not Git, but it tries to be a bit like that. So, here's the solution, but I won't try and explain all this to you in my previously. So the first thing, here's your Liquibase server, and talks to your database. And it's just applying patches to the database. The only interesting thing it's doing, beyond that, is that you have an XML file which determines what the SQL scripts are that should be run. Sorry, it's XML. And in the XML file, you can also have these tags. What happens is that the database gets a new table called the database changelog. and even if you use Postgres, it's just a top-level table anyway. So it's got a database changelog. It tells you which scripts have been run, and it also, if you put a tag in the XML file, it puts another row there saying these scripts have been run. It's all cool. In fact, it has an OK column or something to say that these patches were successfully applied. So that's what the XML file looks like. That's the tag I was talking about. There, the include file, that's just almost a plain SQL file. The only difference is the comment at the top, which is Liquibase formatted SQL, change set, blah. That is what gets plugged into the changelog table in the database. It's also got this. So if things go really bad, then you can run Liquibase rollback, and it runs that comment in your SQL code to undo the changes. Unfortunately, it doesn't record in the changelog table that you run on the changes. It actually deletes the row, so it never happened, which I'm not sure about that. So this is just running Liquibase at the command line. You give it a change set. You tell it this funny, I don't know what you call this, URL, IRL. What's the word for that?
DSN.
Sorry?
DSN.
DSN, yes.
Yeah.
For telling it in a Java way what it is that you're doing to the database host, which is, thank you, which is DD1. And update, it says apply these patches. And then rollback, as I said, just say Liquibase rollback to version 1.0.0, and it does it. And that's roughly the record in that changelog table. Now, Liquibase Git, what is this? It's a module I've written. I'm sort of maybe going to publish it soon on CPAN. What does it do? So we use Git as the version control of our apps. Our apps within Git, one of the directories, has the patches to the database. Does anyone else have that pattern? There you go. Who has their database patches in a completely separate Git repo? Okay, we can still use it. So it's been so it just checks out your app's code on the Liquibase server, looks in the directory, you tell it to look for the patches and runs them, as I've shown you. So it's a very thin wrapper. It just needs to know where your Git repo is. So here's a call to the Liquibase Git, your username that has access to update the database name, the host of the database, the Git repo you're meant to be checking out from, and what you're meant to check out. So it could be master or it could be a change hash. And right, so the next thing is an app Liquibase, which I can't go publishing because it's Netaport specific. But this is Puppet essentially generating that call to get Liquibase Git. What I do is, who's familiar with Puppet at all? Anyone? Okay, so Puppet is just a way of managing what gets deployed on servers without having to have a different config file in your Git repo for every box that you're installing on. So Puppet manages all these config parameters somewhere separate from the app code. And so you say, take this code for the app, take these config parameters, glue them together, and push it on that box. And that's how Puppet works. So this is what we have in our Puppet config file, which says that for Liquibase, I want you to update these two databases, and then what Puppet does for you is to run this command, literally this command saying apply from this repo the patches with that identifier. So what this Liquibase call did is it looked at the public database to say, hey, I'm going to act on these servers. What are the config parameters that I need? And run Liquibase get on, which is running Liquibase. And then all this takes place at Net with Jenkins driving it. So Jenkins is, for the most part, what runs our unit tests and promotes apps from dev to pre-live to production. And so Jenkins, you click the button on Jenkins for this app and it runs the unit tests and then you say promote. And what it does, it says, oh, I'm about to deploy it to live. So I am going to, first of all, ping the Puppet database and say, which boxes is that for? And it then calls this big arrow, 5 minutes, yeah, to Liquibase and says, please update the patches, or the database refactoring for that box, the live box. Liquibase then calls PuppetDB to find out the other parameters like the Git repo, the branch or commit, whatever it is that it should be using, and it will calculate its down the way I showed you. Right, so that was the good news. The bad news is that this has not made it that easy for developers yet, because they don't have Liquibase installed in their boxes unless they're Java developers. The Perl developers don't. And if I asked them to install it, they would vomit. So what we've done in the back end Perl development code is people have written fake Liquibase, because as you know, Liquibase is very simple as long as you're not rolling back or trying to track what you've done. So it just pretends to be Liquibase and applies the patches. It's 3 lines. The other option was to call Liquibase get to update a DB dump, right? So the way that we work on some of our systems is that we don't build a database from scratch when we do unit tests, or when we develop our own box, is we get a dump from the live, scrape out the private stuff, and just install it, and then get Liquibase to run it on that dump, as though it was just the most recent patch. So this is the way we use it. It's not perfect. So, it's a very honest talk. The coloured ones are things you shouldn't do. The white one is what you should do. So you shouldn't write a new DB refactoring code for each app, because it's ridiculous that you've got like 100 lines for every app to do the DB refactoring, when actually, if you have it as a service, you don't have to install anything new on the app's box. Don't go deploying the refactoring code on the app's host, particularly if it's Java. It's disgusting. And don't assume you only have one app, 1 DB per server, okay? Because then you can't scale. So it makes sense to pull that out and put it on a service. Not saying you should use necessarily my module, I'm just saying separate it from the app's box that was patching. And that is almost it. Except that when I gave this presentation at Net, Ilmari, who knows Ilmari? Is Ilmari here? Is Ilmari know? He's not even here. So Ilmari said, because he maintains DB. And so, does he still maintain DB? No? Yeah. So he said, I've heard about this Sqitch thing, you might have a look at that. And I've had a look at it, and it's sublime. It's new, it's Perl, and it is so close to Git. I think that Liquibase is like CVS compared to Sqitch. So in my spare time over the next couple of weeks, I plan to move what we've done to Sqitch. I don't know how to pronounce it. It's very strange.
Sqitch.
Yeah. And so this is real. I should actually ask him for pronunciation. That's all I can say. Other than, oh, no. So the main thing about Sqitch that will hopefully sell it to all developers is that it's so small and simple to install up and get 514 or something on the Java box. But it's simple to use, simple to install, and they can run the patches as they would in real life on their own boxes.
There is a section on Floss Weekly, the podcast, and they are featuring Sqitch on Floss Weekly. Recently, something like, I'm not sure, 4 weeks ago. 4 weeks ago, yeah.
It's something that one reads or one watches.
You listen to it.
Okay, podcast. Thank you.
What do you do when your application code and the database version don't match when you deploy the database first?
Then, so you do the database patch, the app code doesn't agree with it, then it shouldn't happen at all. Because, well, so first of all, Jenkins will say this app relies on these versions of the database, and so what it should do, in fact, is not touch the app. I mean, so the app, you do the RPM, install, it fails, you uninstall the RPM, install the old one, it should all be fine. If you're playing by the rules of the database patches. Okay, only one more question.
What's the granularity of the sort of dependency? Does it say you can't roll this feature until you change this table, or is it like this version of the application depends on this version of the whole database schema?
That's how we're doing it.
That.
Yeah.
I just wanted to ask your cause ID.
Sorry?
What's your cause ID?
I forget. Illy, I think. Might be Illy.
D.
Illy.
Oh, right.
Cool. I think. Hey.
Thanks.
But it's not out yet.
You've got version numbers, which implies they have to be installed in order. So
No.
So can you have two versions which are both kind of like building on the current version and not care which order those two
Yes, you can.
upgrades are done?
Yes, although it goes in the order of what's in the XML file. However, if you go to Sqitch, it's completely Git, and you don't use numbers. I think that's the side that you have to go.
Is anybody missing a leather jacket which was found in here? No? Okay, cool.
Very lengthy.
Okay, right, well you just have one version. The problem is, it's up to you, but essentially every time you do a project,